Hello everyone, time to resume. So next speaker is Professor Robert Adam from the University College London, who is going to tell us about unimodal code switching between two sign languages, some findings. So I'll introduce Professor Adam.
Arigato, good afternoon, everyone. It's great to be here in Osaka. I would like to extend my gratitude and congratulations to you on hosting this conference and say my hellos to everyone who I know out here in the audience. I'm going to be using American Sign Language today, which is not my first sign language. So bear with me as we go through my presentation. My title is Unimodal Code Switching Between Two Sign Languages, Some Findings. Here's a breakdown of my talk today, some background I'll go over. I'll talk about my research questions, my methodology, who was involved in the project, and some statistical analysis, and my findings at the end. We're talking about contact between two sign languages, Irish Sign Language and British Sign Language, ISL and BSL. These are genetically unrelated sign languages. They do not come from the same sign language family. American Sign Language and the Sign Language of France, LSF, belong to the same family, and ISL belongs to that family, but British Sign Language is in a different family. Fingerspelling systems between the two sign languages, ISL and BSL, are completely different. ISL using a one-handed system and BSL using the two-handed system. BSL is an indigenous language in the United Kingdom. Whereas, as I said, ISL is a member of the LSF family. When it's time to set up a deaf school, historically, the French method was the one. This is how we know that sign languages are related, is when you research how deaf schools were formed, and you see that if the French had an influence on the founding of the school, then French Sign Language was used, and the other sign languages were derived from that. ISL was used in Ireland for many years, but then when BSL became the language used to establish schools, it started to disappear. So this is a similar situation to spoken language, majority language, minority language situations. And so I'm investigating that same sort of phenomenon among two sign languages. A lot of the research on majority-minority language interaction has to do with spoken language, and we don't have much in the area of sign languages, where a majority-minority condition exists. So my research consists of that analysis, the contact between two different sign languages. This was the subject of my PhD research on code switching between the two languages. It was a sociolinguistic study about the cost of code switching. I'd like to show you an example of BSL and Irish Sign Language so you can see the differences. The first example will be BSL. So that was an example of BSL. British Sign Language. Now we'll show you ISL. Okay, so you can see in the same content being interpreted into the two different sign languages, you can see clearly the differences, a two-handed alphabet as opposed to a one-handed alphabet. Now, looking at, of course, my research is on code switching in sign languages, but if you look at the spoken language research on code switching, you see that Muter and Allport found that there is a reactive inhibitory control which controls switching. Their research found that people who are bilingual in L1 and L2, that there is a cost when they code switch into their L2. The cost is larger actually switching from the L2 to the stronger L1. Costa and Sandesteban also found that L2 learners had an asymmetric switching cost. A similar finding. So again, they found that switching to the L1 is harder than switching to the L2. So it suggests that there is an inhibitory mechanism at work. And also that proficient bilinguals were faster in tasks where they had to name pictures in their L2 rather than their L1. Costa and others in another experiment found that there was a cognate facilitation effect in a picture naming task from the languages Spanish and Catalan. The response time for naming cognates was shorter than for naming non-cognates. So when they saw a picture where there was a similar word in their other language, they were able to name the picture faster than when the words were different. This also has to do with Christoffel's work, who found that there was a cognate facilitation effect going on in this experiment. So given what the findings were from spoken language research, I was curious to know if this would apply to the situation of two sign languages in contact with each other. And I did know of a bilingual unimodal situation with Irish Sign Language and British Sign Language, and so I wondered which was faster, switching from BSL to ISL or from ISL to BSL, and would there be a cognate facilitation effect? One of the difficulties with using a cognate between two sign languages is the whole definition of cognate is that the two languages have to have the same language family, but Irish Sign Language and British Sign Language do not have the same sign language family. However, since they are visual spatial languages, there are many similarities, and so you might call them pseudocognates, or there might be a possibility that they have many pseudocognates. So I chose people who had ISL as a first language and BSL as a second language. Brought them together and ran experiments on them. They were brought together and given a code switching task. They were shown pictures of 18 different items, 18 different pictures using two different colors. So for a total of 36 different slides, 18 of them in the blue, 18 of them in the red. Of these 18, 7 of them were similarly produced in the two sign languages, and 11 of them were not similar in the two sign languages. Similarity or dissimilarity would depend on the number of parameters the signs shared, such as hand shape, location, and movement, and non-manuals. If they were dissimilar, that would be the case where they shared 1 or 0 parameters. And I'll go into this in detail later. So I had to search for lexical signs from both languages, from their dictionaries, that would match the pictures of the objects I had. They were shown the objects in blue and red, so I had to have the objects produced in those two different colors. And I would tell the subjects, when you see red, use BSL. When you see blue, use ISL. For the other group, I would say, when you see red, use ISL, and blue, use BSL, so that they were randomly assigned the colors, and I would try to remove the effect of color on the results. So again, I'll give you examples of the pictures. But first I'm going to talk about these pseudocognates. The ISL sign for world is one that I will show you now. Okay. To the right is the BSL sign for world, produced differently. But only in one regard, the hand shape. So those two are very similar, pseudocognates. So my question is response time going to be faster when the subjects are presented with an image of the world? Because these are pseudocognates. Even though ISL and BSL are not from the same language family, they're still considered pseudocognates with regard to that sign because they're formed so similarly. Now I'm going to show you the sign for man in the both languages. The ISL sign, the BSL sign. An obvious difference between the two. They're made completely differently. So I was curious to know, will this affect response time when a picture of a man is presented to the subjects? How will that affect their response time when they're asked to produce it in the two different languages? So now I will show you the actual task. First, I had to get a benchmark for each subject just to see their response time responding to things in one language without having to switch. So I could get their response time just working within their own language with no switching. So they were given 36 of these pictures at the interval you just saw, short, just 1 or 2 seconds, and then they would be presented with this "Are you ready?" slide after having seen 18 of the pictures that had gone by previously. Now, I'm going to go ahead and start this now as if you're the subject, so see how you do. Are you ready? So the participants were asked to name the 18 pictures as quickly as possible, and their response times were timed. Now, the initial 36 were presented. They were asked only to produce it in their own sign language so that I could get a benchmark in one sign language. And then they were given 150 different trials. So once again, I'll show you. So you can, again, the first trial there's not required to do any switching, just stay in one language. This way I got a benchmark for each person, and then for the testing, 2 blues in a row meant no switching, but when you see a red, you have to switch. Now you switch back to blue again, stay within blue. Once you see red, you have to switch to the other again, etc. So we were able to calculate response time for each subject. I initially chose 13 people, but I had to exclude 2 of them because they made too many errors. So 11 participants were ultimately coded. All were bilingual in ISL as their L1 and BSL as their L2. The subjects were tested in Dublin, Belfast, and London. Now, one of the challenging aspects of this research is finding the right kind of software that will allow me to code their response times. There's plenty of this software available for spoken language, but how do you handle coding sign language? It's a big challenge to do this. There's no voice activation for response time available to us. So I had to develop a list of protocols in terms of how we would measure the actual onset of a sign. I was using the software called Elan, which is a very specific format. It's visual, it's designed to use video. But I still had to decide where would be the time we call the onset of a sign. And for me, it would be, first of all, when the initial handshake was fully formed. Actually, I had 4 different criteria. The first of which was when the internal movements in formation are completed. For example, when you make the letter F, the index finger must make contact with the thumb. So I would not start coding until that contact was made. If there was no internal movement in a particular sign, such as the sign man, I would code it from the time that the sign met its orientation. So when the time the signer is positioning their hand into the position to make the sign, that's when time started for the reaction time. In letter C, as you see here, if it's a 2-handed sign that makes contact after the initial movement, such as world, I coded from when the signs were at their most extreme location. Because the hand shapes were fully formed. If it's a 2-handed sign, where the 2 hands do not make contact, well, let's go back to world again. I would have to go to where their highest point was of contact, or their lowest point. But in the case of world, start with the highest point. If any of those conditions didn't apply to a particular sign, I could always use their elbow movement and start it where their elbows finally rose to the correct position where they were able to start making the sign, and use that as the onset point. So I had my criteria ready to be able to calculate their response times. And so I divided my data by the pseudocognate signs and the non-pseudocognate signs. And after doing statistical analysis, I found that indeed, pseudocognate signs had a much stronger advantage for switching. I used a 2x2 ANOVA using SPSS. Here's a graph of my results. So you can see that switching from BSL to ISL, and then switching from ISL to BSL seem to not have an effect. They seem to be, you would think it would be the same as the spoken language research, but it was the reverse. There seemed to be no switching cost. If you look at ISL and BSL, staying within those languages, there still was a cost, regardless. The differences between these staying and switching was not statistically significant. So yes, sign languages do have a switching cost, but not to the same extent as you see in spoken languages. If you look at the blue line, you do see that signs that are not pseudocognates do take longer to switch between than those that are pseudocognates. So there is a switching cost, and there's also the cognate facilitation effect going on. So it means that where the signs are not cognates, the reaction time is longer for where there is a switch than where there is a stay trial. And it also shows that both the stay and switch trials are quicker in ISL than for BSL, which you would think would be the other way around, because spoken language research says going from your L1 to your L2 should not have as great a cost. The other thing I also found interesting is that they were able to produce ISL signs quicker at 1053 milliseconds as opposed to 1135 milliseconds for BSL. So there was a difference in the response time for production. So as I said before, it appears that there is a pseudocognate advantage, whether or not there has been a switch. So there is a cognitive facilitation effect, cognate facilitation effect, and that seems to be stronger or outweigh the switching cost effect. So with regard to further research, obviously, we need more subjects. We need to see if this kind of result is reproducible with larger numbers of subjects and if the same statistics will be found. And then also, we need to go to where different geographical regions, the people in Dublin may react to this differently than people in other regions of Ireland. And so we need to see where certain language context situations are variable. This is psycholinguistic research. And we may want to look at the actual sociolinguistic situation in the areas where we're doing the research with regard to language attitudes. Is the use of the language encouraged where they live? Because these things may influence their production of the languages. In my PhD, I did that sort of research, both psycholinguistic and sociolinguistic. And this is the end of my presentation. I would like to thank Professor Albert Costa for his assistance and Professor Karen Emery for suggesting my research methodology. I'd also like to thank my PhD professors and examiners, Ben Sewell and Gabriela Viglioso, for their guidance and support, and of course to all the subjects. Arigato, thank you very much for inviting me.